Today, we dismantle a persistent myth that injecting CO2 into blast furnace tuyers reduces emissions. As metallurgy and thermodynamics expert, we will prove in uh, approach increases this approach increases carbon footprint. Then we reveal the proven alternative like top gas recycling. Now, as we know, CO2 cannot reduce iron oxide, only carbon monoxide and hydrogen can, forcing carbon dioxide into the tuyere triggers the Woodward reaction. CO2 plus C is equal to 2CO. These consume precious coke to create reducing gases. Thermodynamically, it's like using a fire extinguisher to start a blaze. Every mole of injected CO2 devours 12 grams of coke just to become useful. It is just a case of self sabotage. So let's quantify the damage. As we have calculated and tried to sensitize that for 100 kg of CO2 injected, stoichiometry demands 55 kg, good number, 55 kg of additional coke to regenerate CO via Woodward reaction. At industrial scale, let us see what's happening. A 5,000 ton per day furnace injecting 6% CO2 would burn 275 tons. Remember, 275 tons extra coke daily. That is not decarbonization. It's a carbon shuffling with a net increase in fossil input. Now, the energy penalty. Woodward is endothermic, as everyone knows. That is plus 172 kilojoule per mole CO2. This cools the raceway drastically. The heat of the furnace, where temperature must exceed 2000 degrees centigrade for the slag formation. CFD data shows just 6% of CO2 injection drop peak temperature by 120 degrees centigrade. So consequences is disaster, poor slag fluidity, slower melting, and productivity loses up to 15%. It's a big margin, 15%. So now unconverted CO2 act as a inert ballast. It dilutes reducing gases, lowering CO partial pressure. This slows reduction kinetics by up to 30%, proven by shaft simulation models. It is O's. Cold dense gases increases burden resistance. The result is nothing but it is a channeling, uneven flow, and potential furnace instability due to differential losses. Direct injection struggles very process it claims to help. Real CFD evidence from a commercial scale furnace with the 6% CO2 injection shows the peak temperature drop 120 degrees centigrade, combustion zone narrows by 40%, coal burnout delays by 0.5 second. Yes, late stage burnout improve slightly as CO2 finally react, but too late. to offset raceway damage. Thermodynamics always wins. So, the conclusion: don't inject CO2, remove it. Top gas recycling captures furnace exhaust, strip CO2 via VPSA, as the details is also attached here, and re-inject purified CO and S2 gases, which has a reduction potential. Oxygen enrichment prevents nitrogen buildup. Result: what is the result? Result at LCAP and ArcelorMittal uh, ULCS pilot. There we can see that there is a 50% CO2 reduction, 30% lower coke rate reduction, 90% gas recycling without thermodynamic penalties. So, a huge benefit, we can say, as a benefited immensely. So now, coming to the our uh, aerodynamics, where we conclude that air blast poisons recycling with 79% nitrogen. It dilute reducing gas, forcing low recycle rates, that is almost less than 30%. Pure oxygen enables 90% gas recycling, that is 75% CO and 15% S2 concentration. 75% CO and 15% S2 concentration. A stable flame, that is 2200 degrees centigrade. Nitrogen isn't just ballast, it's a thermodynamic lockdown. Oxygen breaks the chain. So now, coming to comparison, and when we compare carbon flow, then direct injection is chaotic. This result into a extra coke bond that we have already discussed in the preceding slides in great depth. Unconverted CO2 escape. Then top gas recycling in the blast furnace. It's a basically elegant loop. There is a coke saving. It's a slash the loss of carbon by 30%. It's also capture CO2, which is 90% pure, goes to CCS. So we can say that the net result is always in terms of profit. That is, when top gas recycling in blast furnace achieve the actual decarbonization. Direct injection is basically greenwashing that we have seen through the thermodynamics and kinetics. Now coming to conclusion, uh, it is all about the direct CO2 injection increases emission via coke penalty, and top gas recycling in the blast furnace cut emission by 50%, today with a existing technology. So what is the next step? Next step is nothing to integrate TGR-BF with green hydrogen and CCUS to the industry, redirect R&D from dead-end injection to scaling TGR-BF. To policymakers, request is to fund VPSA infrastructure, not thermodynamic fantasies. The science is clear. Let's build the future. We have shown only CO2 injection fails metallurgically, thermodynamically, and environmentally. Thank you.